Okay, we'll be starting a unit on rational expressions today. Okay, here's the two learning targets I want to focus on. I can find the domain of a rational function. We found domain of many different types of functions already, so this is kind of review. So I'll recap that with you, and then we'll work on simplifying a rational expression. Keep it kind of short today, okay? And then we'll finish the rest on day 2. Okay, so review. Find the domain of the function. If you want to pause and write this down, go ahead. These are some things to remember when finding the domain. Sometimes the domain's all real numbers, and it's that simple. However, we got to be aware of situations where we might be dividing by 0. We can't do that. So we got to get rid of those restrictions on x. We also got to be worried about taking even roots of negatives. Okay? So if we had a problem like f of x equals x squared minus 6, our answer immediately would be all real numbers, negative infinity to positive infinity, for finding the domain, because there's nothing in the denominator. The only thing that's in the denominator is 1. Okay, but if a variable's down there, we have an issue. Okay, so we should be able to see it just by, this is easy math, right? 4 minus 4 gives me 0. So x cannot equal 4. Everything else is fine. Okay, so this one is, we could say x can't, the process is take the denominator, set it equal to 0 and solve it, right? Okay, so for more complicated things, that's what we'll need to do. All right, add the 4, we get x cannot equal 4. Or, in interval notation, we do it this way. Negative infinity up to 4, not including 4 with parentheses, and the union of 4 to infinity. Okay? Oops. All right, good time to pause and try 2 and 3. So go ahead, find the domain for those two. Okay, here's your feedback on that. So we're setting this denominator equal to 0. We can factor this, set both those equal to 0, we get negative 3 and 1. Okay, so there we go. I don't care if you write it this way, but obviously multiple choice will probably be expressed in this format. All right, and then there's number 3. Okay, now none of these had even roots and negatives, so that might look something like this. If I call this problem 3b, maybe we have a function that looks like this, the square root of 3x minus 12. Now we're taking an even root of an expression, so we got to be worried about taking square roots and negatives. So what we do under this scenario is we take the expression and we set it greater than or equal to 0. And then we solve that, and then we have our domain. So here I'd add 12, and then I'd divide by 3, and I'd say there's my domain. X has to be greater than or equal to 4, okay? All right, so most of that's review, but we're reviewing it because it fits with rational expressions. By the way, rational expressions is any expression that kind of takes on the form of A over B. Okay, that's the definition of a rational number. And rational expressions are fraction form, as you kind of take a peek at this whole page, right? We see fractional expressions. All right, so moving on to this next step, write the rational expression in simplest form. Here's something you're going to want to jot down. And I'm going to go quick because I know you have the ability to pause. To simplify, you're going to find the common factors, okay, rewrite it with those common factors in mind, and then we'll divide out those common factors and replace them with 1. So it's going to look like this. Now, there's another way you can do this, but I want to make sure you understand to simplify these, that's what we need to do. Okay, divide out the common factors. So what's the GCF of these two terms? Well, they both have a 5 in common, and they both have an x cubed in common. All right, so I'm going to rewrite this with the common factors. So 5x cubed times what will give me 20x to the 5th? Well, I'm going to need 4x squared. Okay, what about down here? 5x cubed times what gives me 15x squared? Well, we're going to need 3, and I'm going to need an x. Okay. All right, so now I express these with the common factor. These divide out since they're the same. Okay, anything divided by itself is 1. So I replace them with 1, and then here's the final answer. 4x squared over, oops, I wrote that wrong, didn't I? Shoot. I got to correct this. Sorry about that. It's 5x squared is in common, not 5x cubed. Duh. So I had to take out a 5x squared here, meaning this is 4x cubed left. This is an x squared. So all this is a 3. Sorry about that. Okay. All right. So when those divide out, we're left with 4x cubed over 3. There we go. Sorry about the mistake. Okay, now there's another way to do this. You could just realize, all right, 20 divided by 15. How do I reduce that fraction? 4/3. Good. And then the x to the 5th over x squared, you can just subtract those exponents if you remember that rule to get to the x cubed. As long as you know where to put the x. Should be up top. Okay, so there we go. Let's have you try too. I'd pause, try it. I'll give you feedback. The GCF you should find, and then I'll stop and let you try it. The GCF, you're going to break this down with, is going to be 8x. Give it a shot. All right, so here we go. 8x times the 4x squared gives me 32x cubed. The 8x's will divide out, and we're left with 1 over 4x squared. Okay? Okay, let's take a look at 3. What can I factor out of these? X minus 3 doesn't have a factor I can take out of both. This one, though, I can take out of 3. So let's write it like this. All right, now notice these signs are a little different. This is positive, that's negative, same thing here. All right, so we're close. So what you might want to try is try taking out, instead of a positive 3, try to take out a negative 3. So try a negative 3, all right? So let's kind of redo this. If I take out a negative 3 up top, just fill in the blank. Negative 3 times what gives me positive 9? I need a negative 3. Negative 3 times what gives me the negative 3x? I just need positive x. Okay, that works. And then the bottom, I have x minus 3. Okay, notice the signs are the same. They're just kind of expressed backwards. I'll try to clear it up for you on this next step. We can write negative 3 plus x as x first and then minus 3 second. Okay, and I have x minus 3 down here. If you're wondering what's left, you might want to write this as x minus 3 times 1, because that's the coefficient of that. And then it's very clear what's left down here. So the x minus 3's are gone, and we're left with negative 3 over 1, or just negative 3. Okay? These are all a little unique, so I'll probably have to, well, I'll have you try 5 on your own. Let me show you 4. Don't forget difference of 2 squares. A squared minus b squared is a plus ba minus b. And this fits that format. So we can write that as y plus 1 and y minus 1. On the bottom, nothing to do there, just 1 times y minus 1. So these reduce, replace with 1, and then we're just left with y plus 1 in the numerator. So there's the answer. Okay? All right, so why don't you try 5, factor the top, because you can factor that, and the bottom, and then see what you get for your final answer. Okay, here's your feedback on 5. Factors of negative 4 that add up to positive 3 are positive 4, negative 1. And then difference of squares on the bottom. Okay, y squared minus 4 squared is y plus 4, y minus 4. We do have a common factor, so we replace it with 1. So our final answer is that. Okay, last one, 6. All right, now notice the numerator is a little out of order. The x squared term isn't first, and it's not 1. Like this one was positive 1. It's going to be 3, so negative 3 actually. So this is going to take a little while to factor. So what I'm going to do is just kind of take this off to the side and work through these factors here, okay? Just going to box this off. All right, so I'm going to rearrange it. Negative 3x squared minus 10x and plus 8. All right, it's not fun to factor when a is negative. I mean, we could. I think it's best just to take the negative 1, take that out right now. Okay, now let's focus on factoring this expression. We'll just leave the negative out here. So we're looking at factors of negative 24. I have a sum of the middle term 10. So I'm going to start brainstorming. Maybe an 8 and negative 3. Nope, sum of 5. That doesn't work. Oh, how about a 12 and a negative 2? That gives me the sum of 10. So that's what I want to use to break this apart now. Okay, still got this negative 1 over here. All right, and then we